Okay, good morning. Welcome to
Math Problems number 153.
Math Problems number 153. So we just started a really fun section in the book about about fractions as decimals, and we saw things like 0.5 equals what?
One half.
1/2, and do you remember what 0.2 was?
1/5.
1/5. Yeah. So we found some really neat things that some fractions actually have really easy decimals.
Cool.
Yeah. But what I want to talk about is one that looks really complicated. 0.99999 and repeating. And that equals 1. And we've seen actually there's a really cool video online. Do you remember? By Heart has a really cool video about this. But I want to show you why this is true, because why would these be equal? Right?
Well,
they don't look like they're equal.
Yeah.
And she makes a great point in the video. Like 0.5 and 1/2. Those don't look like they're equal. It's not good. No. They're very different. It seems like they are, right? But they represent the same thing.
Cool.
So why are these two things equal?
Well, you could round, and if you rounded to like any decimal place, so it'd still equal 1.
Oh, very interesting observation, actually. Hey,
round.
high five. I wouldn't have thought to talk about that. Very good. Let's actually talk about it that way. Double high five. That was a great idea. Let's round.
You can round to any decimal.
Round to the 10th. What do we get?
1.
1. Round to the 100th. What do we get?
You still get 1.
1. To the 1000th.
1.
1. So now we're going up 3 places. 4 places?
It's still gonna be 1 because every digit is 1, and every digit is 9, and then you look for rounding. You look for the digit, and then you look for the digit behind it, and that's in front of it, and that's always 9. So you always round up to 1.
Right. So no matter where we stop. See, if this was different than 1, somewhere we would have to round to some other number, probably, right?
Yeah.
So like we looked at the 10 to the 1's digit, and that goes to 1. The 10 squared is, well, sorry, let's say what the digits are. The 10 to the 1 minus 1 digit, sorry, that's why you were confused. The 10 to the minus 1 digit is a 9.
Yeah.
The 10 to the minus 2 digit is a
9.
9. The 10 to the minus 3 digit is a
9.
The 10 to the minus
4.
1,000th digit is a
Still a 9.
9. The 10 to the minus grams number, still a
9.
So no matter what digit we're at, we're always a 9, and it always seems to round up to 1. And so there's never a point
where you can't round to 1.
where it wouldn't round to 1, and if it was a number that was different than 1 somewhere,
you'd have to round to something else.
Yeah, so for example, the number 0.9999, where we stop there.
Yeah.
This doesn't equal 1 because the 10 to the minus 1, minus 2, minus 3, minus 4, the minus 5 digit is 0.
Yeah.
So if we round this to this decimal, or even this one, to the nearest 10 to the minus 4, we would actually get a number different than 1. Very interesting. Hey, high five. I like the way you thought about rounding. So it certainly rounds to 1, but now let's do a quick proof right at the end. Let's call this number x. What do you think I get when I multiply this by 10?
Well, you shift over 2 decimal places, so it's gonna be a different number.
How many decimal places do I shift over
You
when
shift
I multiply
over-
by 10?
You shift over 1.
1. So what number is this going to be? 0.99999 when I multiply by 10.
It's still gonna have all of those 9s, but it's gonna have 9.999, which is gonna be 10.
This is 9.9999999. What happens when I subtract 10x minus x? What do I get?
You get 9x.
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 What happens when I subtract 9.99999 minus the 0.99999? What do I get?
You get 9.
So 9x equals 9.
9x equals 9, and those can't be cancelled.
So I can divide both sides by 9, right? And what do I get when I divide both sides by 9?
You get just x.
X equals
1.
1.
Whee!
Wee. All right. Well, that was cool. I like your rounding idea. No matter where you round, you always round to 1, and then that must mean it's equal to 1.
Cool.
Cool. Hey. Awesome. High five. That was awesome.
Yeah.
Good job. So 0.999 equals 1.
Cool.
Repeating, I mean.
Yeah.
Right?